Okay, hello everybody. This is Brian O'Neill. I'm doing problem 11.2 this time. So for sigma equal to this stress tensor right here, determine the traction on a plane with, oops, sorry, I just smacked my camera stand. Determine the traction on a plane with n equal E1 over 3 plus 2 over 3 times E2 plus 2 over 3 times E3. Okay, so our traction equation is T is equal to n dot theta, which is quite easy to do. It's plug and chug at this point. So we have our first T component, our second T component, our third T component is equal to this times this times that, and we get this set of equations over here pretty much. Um, we can just substitute everything in. So we get negative 1/3 minus 4 over 3 is equal to our first T component, which is negative 5 over 3. We get negative 4 over 3 plus 4 over 3 is our second T component, which is 0. And we get 4 over 3 plus 2 over 3 is our third T component, which is 6 over 3, which simplifies to 2. And so we have our traction vector that I've written out right here. Okay. So the next part is to determine the magnitude of Tn and Ts on this plane. So to do that, we set Tn equal to the um, n dot t using n and t that we just had. We get this equation here. Everything that's E1 and E1 and everything where it's the same E dotted with itself is 1. Everything where E is not dotted with itself is 0. So you only have to worry about these two, those two, and those two. And the rest of the equation we don't need to write out because everything else is 0. Doing that, we get this equation here. Solving that, we get 11 over 9 as our magnitude. And to find t sub s, we take the equation for t sub s, which is t dot t minus tn squared. Plugging in numbers again for that, since it's all nice and numeric this time. We actually have just a set of values on the right side. Plugging and chugging that set of values, I converted it uh to decimals for the end, so I can just plug it in my calculator. So since TS is squared on this side, we have to take the square root of both sides. And finally we get TS is 2.3934.